Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video, we are going to discuss the warming of air from underneath or from the surface. We will put together all the concepts that we learned in previous videos, and that's conduction and convection of heat, as well as various concepts associated with radiation, solar radiation and terrestrial radiation, and then we will see how these processes contribute to the warming of the atmosphere. To do that, let's represent Earth's surface like so. So this is the surface of the Earth. And what are now the processes that we need to consider when we talk about warming of the atmosphere above Earth's surface? Well, we saw that first we have shortwave solar radiation. So let's indicate it like this. And we saw that part of this radiation is passing through the atmosphere and reaching Earth's surface. So this is short wave radiation. And this is how we defined it in previous videos, solar radiation or short wave radiation. So part of this radiation reaches the Earth's surface and the surface absorbs it. We can immediately connect this absorption of solar radiation with the process of conduction. Namely, molecules and atoms that absorb this radiation are jiggling more than the average. And therefore, if these molecules jiggle, they transfer that jiggling to the air molecules adjacent to the surface. And now these molecules jiggle. And this transfer of energy through jiggling, as we know, is known as conduction. So the atmosphere is warmed by conduction. And that's because Earth absorbs solar radiation, jiggles more, and that jiggling is transferred to the atmosphere. Now, once conduction starts, then this parcel of air over here is warmer than the surrounding atmosphere, and this parcel of air can now, we would say, rise. And this is known as convection. So conduction is necessary for convection. And you will remember from my video on convection, convection can only happen in fluids, namely gases and liquids. Now, if we have water vapor that is present in this parcel of air that is rising, we might even have cloud forming here. And cloud means condensation of water vapor. So condensation releases latent heat. So that's yet another source of heat for the atmosphere. Namely, latent heat of condensation of water vapor or deposition if we go from water vapor to ice. So you can see that this solar radiation that is absorbed can be transferred into heating the atmosphere through these three processes: conduction, convection, release of latent heat. Of course, some of the solar radiation is directly absorbed by the atmosphere. Let's say here, it didn't reach the Earth's surface, it was absorbed here by some molecule or atom in the atmosphere, and then of course this can additionally contribute to conduction, convection, and then through convection we can have release of the latent heat. This release of the latent heat is also associated therefore with evaporation of water from the surface, because if we have condensation of water over here, that water had to come from somewhere. Well, it came from the evaporation of water from the surface. And evaporation mostly happens over oceans, then seas, big lakes, a little bit rivers, and a little bit the rest of the planet, namely forests and other features on our planet. And lastly, we also have terrestrial radiation being sent back to the atmosphere and to the outer space. This was shortwave radiation. Now, part of this energy that is absorbed is also re-radiated in terms of long wave radiation. And we call that infrared radiation. Now, part of this radiation, and you will remember from previous videos, particularly between 8 and 11 micrometers atmospheric windows, directly goes back into the outer space. What goes back into the outer space does not contribute to warming up the atmosphere, but some part of this radiation is being absorbed in the atmosphere by molecules and atoms. Let's say this molecule absorbed this infrared radiation. Now the option is this molecule can re-radiate this upward back into the outer space, but it can also re-radiate it back towards the surface, thereby warming up the surface, or another molecule close to the surface will absorb it, thereby heating up the air. Once this radiation is returned to the surface absorbs it, and now once surface absorbs it, it can either radiate it back as radiation, or it can be used through the process of conduction and convection, or it can be used for evaporation of water, water from the surface. So, to summarize this, how is the atmosphere heated? How is the air heated? You can see that predominantly atmosphere is warmed from underneath. Very little of solar radiation is directly absorbed by the atmosphere. Typically, Earth's surface absorbs radiation, and then the air, the atmosphere above the Earth's surface is heated through infrared radiation, through conduction, convection, and release of latent heat. Of these processes, dominant factor is this absorption and re-emission of radiation and release of latent heat. Conduction and convection are smaller than these processes, but their exact percentages will be discussed in the next video. Lastly, I would just like to mention that these molecules that are absorbing infrared radiation in the atmosphere are predominantly water vapor and carbon dioxide. And these are two most important greenhouse gases, which I discussed in previous video. And in addition to them, we also have methane and nitrous oxide, but these are the dominant absorbers that keep our atmosphere and planet Earth warm. Until next video, goodbye.